Hey everyone, it's Dr. Hawkins. Today is experiment 22, very close to the end. This one's called Stay Hydrated because we're using hydrates. What is a hydrate? A hydrate is something that contains water in their crystal structure. A desiccant is something that absorbs moisture. And we're going to see this kind of process firsthand in lab. There's lots of examples that are listed there, drywall being one of them. Drywall is a good example, we'll see it later. Drywall, also called gypsum, is not actually too dry because it contains water molecules in its crystal. Important for fires because when the fire heats up the drywall, it produces water, slowing the burning process. So what we're going to do for lab today is take a hydrate that has water, heat it up until there's no water left. We're going to do that with apples, we're going to do that with cobalt compounds and copper compounds, and we'll come back and show you what's going to happen with the apple first. It's kind of like a decomposition. We take one product, one reactant, and turn it into two products in this case. So we'll come back for lab. Alright, so our first experiment is dehydration of an apple using the oven. So we're going to take a piece of apple about 2 grams in size, put it in our evaporating dish. So we're going to put that in there and hit 0, much like before. I'm going to take an apple out, look like all the food care workers right now with my gloves on, and probably break off a small piece, toss it in, and we'll come back with that weight. Alright, for purposes of our lab book, the mass was 2.153 grams, and now we're going to take it to the oven. Alright, we're going to put it in the oven and let that guy dehydrate, because fruit is mostly water, for about an hour. We'll come back. Alright, so hopefully you recorded your observations. We just had a kind of shiny, wet green apple. And now after an hour, we're going to take it out of the oven and record our observations. And then we're going to reweigh it. Alright, again, for purposes of the lab, we got a 0.3666 grams. And then up here, again, is our dehydrated apple. So we're going to go ahead and complete the other 2 experiments, but there is some busy work associated with this. We'll come back to all the busy work at the end of the 3 parts. So basically rinse and repeat with cobalt chloride and eventually copper sulfate. So we're going to take 1 gram of cobalt chloride and then put it into a beaker. And then instead of the oven, we're going to use the Bunsen burner to get rid of all the water. So we're going to take out 1 gram of cobalt chloride. Notice for your observation purposes the color, at least initial color. And we're going to add our 1 gram, and then we'll come back when that's over. Alright, here we have our 1.016 grams of cobalt chloride. That goes in your hydrated cobalt chloride mass. You already have your observations, so now we're going to take this to the beaker and to the Bunsen burner. Alright, we're going to put our roughly 1 gram inside. We're going to use a watch glass as a lid. It's going to go on top of the Bunsen burner, and we're going to recognize any color changes that happen as it becomes dehydrated. So notice we have some fog. That's the condensation from the cold glass getting warm. It's also an indicator of when our experiment's done, because when there's no more fog up top, there's no more water to remove. So notice our crystals starting to get warm, starting to change colors. Now you can start to see the edge of our beaker turning colors. So notice it's starting to dehydrate. So record those observations of this dehydration now. So notice we have some bubbling. That's because there's so much water inside there. I'm going to take this lid off and remove any kind of fog. It's a good indicator of when it's done. If we see fog, we know it's still going. So we'll come back when there's no fog left. Notice the color changes now. Alright, notice now there's no more fog on top. It's pretty warm. But no new fog means it's done. I'm going to take this off and set it on the counter. Very hot beaker. And let it cool down to room temperature so that we can go weigh it. Alright, so we have our crystals. They've cooled down a little bit and we're ready to weigh them. So you should already have your hydrated color and now our dehydrated color, and what's missing is the dehydrated mass, which we're about to find now by adding this to our paper. So we'll come back with that number. For purposes of the lab, we have 0.555 grams. And the last test we need to do, other than the math we'll just do at the end, is this is dehydrated. So if we take this out and put it on the table, what do you think is going to happen if we add water back to it? So here's your last observation for this page. Notice it's changing color once again. As it reabsorbs that water, it gets very hot because it takes that energy very quickly. And then if we get it wet enough, you can almost see that red color start to come back. Just like before. Alright, moving along to page 157, we're going to take now copper sulfate hydrate and do the exact same thing. Take 1 gram into a beaker, put it on the Bunsen burner, cook all the water out and so forth. So observe the original color of the hydrate now, and we're going to take 1 gram out, and then we'll come back with that mass in a minute. Alright, we have a mass of 1.375 for copper sulfate, so record your observations and now record your hydrated mass. And then we're going to take it to the Bunsen burner. Alright, here we are at the Bunsen burner. We're going to add our roughly 1.3 or so grams and take it up top to the Bunsen burner. Our watch glass so we can monitor the loss of water. Turn the gas up a little bit and observe any color changes now with copper sulfate, much like we had earlier with cobalt chloride. Notice no fog yet. We're starting to see a little as the beaker heats up. That's the condensation that needs to be removed, but also watch the crystals. Notice they're starting to change color already. They jump around a little bit because they'll probably build up a little static. But notice the loss of their blue color. So we're going to come back here in a minute or so when we have more of a color change. A couple minutes in, notice we're starting to get mostly white. It's got a little bit of blue left, so we're going to move our Bunsen burner over that direction. I still have quite a bit of water forming up top, so definitely still dehydrating. We'll come back when that dehydration is complete. Alright, we have pretty much all the same color now, so we're going to take off this lid. It's very hot. This one took a little bit longer to do what it needed to do. And then take off this very hot beaker. Set it on the counter to cool. Luckily it's Pyrex. And we'll come back when it's cooled to room temperature. Alright, so we have our hydrated mass from before. You should have your hydrated color from before. We just found the dehydrated color. Now we need the dehydrated mass. This is our last mass before we can go to the busy work. So here's our balance, already zeroed out. Here's our crystals. They're going to go on top. And now we're going to come back with a weight. Alright, so here we have, for purposes of our lab book, 0.881 grams to record, and then we'll come back for all of the busy work. Just kidding, we need to rehydrate it. So here's our before, here's a little bit of water, and notice the rehydration. Every time we add water, notice how much heat is produced. So all that heat that we used to get it out, it's now producing on its own as it reforms. So pretty cool. Alright, so we're back on page 154. We're going to crank through all the busy work, students' least favorite part. But really all we're doing is the before and the after. So if you take the before mass with all the water in the apple, we subtract the leftover apple mass that's dehydrated, we should equal water mass. So find that number now. Alright, so once you find that number, we're going to take it down. That's our piece. Technically, in our situation, that's our water mass because that was the water that evaporated. And we need the hydrated mass underneath. So take your answer here, put it on top, put your 2.153 grams on bottom, times it by 100. So again, this number will be here. And that'll give you the percentage of water in an apple. And this page is done. Alright, so rinse and repeat. We have our mass before with our water. We have our mass without our water. So subtract and get that value. This is our water mass. Our hydrate mass goes here. So put your water mass there, divide it by 1.016 grams of the original, times it by 100, and that'll be your percent water in our cobalt chloride, and you can do that now. Alright, so what I should have done is gotten 0.461, plugged it on top. So again, that number there on top, this number there on bottom, times it by 100, and we get 45.4%. We're going to take that one to the next page. And it says now, calculate the moles of water. We just found the grams of water, but more importantly, we found the percentage of water, which we're going to use as grams. So again, convert your percent water to grams. So we had 45.4 grams. So we're going to put that here. Grams of water, 45.4 grams H2O. We're going to convert it to moles through the periodic table. You know, in 1 mole of water, we can find on the periodic table grams of water. This is going to be H plus O. And that's going to give you about 18.02. Grams cancel. And we should get moles of water. Let's do that calculation now. Alright, so you should have gotten 2.52 moles of water. Now we're going to do the exact same thing for cobalt chloride. And if we know that 45.4 grams is water, or the 45.4% water, the remaining percentage, or in our case the remaining grams, should be our cobalt chloride. So think of what it takes to make 100%, or in our case 100 grams. We're going to bring that down, zoom out a little bit so you can see the two side by side. So if this is 45.4 grams or percent, that would mean this would be 54.6 grams or percent, but now of the anhydrous compound cobalt chloride, meaning without water. Very similar. Get rid of grams cobalt chloride and 1 mole of cobalt chloride on the periodic table. So this will be cobalt plus chlorine, and you'll get 129.83 when that happens. And then lastly, go ahead and calculate your moles. Alright, so you should have gotten 0.421 moles of cobalt chloride. Now that we have a mole to mole ratio, we have our moles of water up top, our moles of cobalt chloride down low. That's just going to be our ratio to give us our waters of hydration hiding in our original formula. So take this one and bring it down on top. Take this one and bring it down on bottom. So we're going to have 2.52 moles of water divided by our 0.41 moles of cobalt chloride. That'll give us our ratio of moles, and this answer will go here. Round to the nearest number. and then use that number here as a prefix. So 1 would be mono, 2 would be di, 3 would be tri, 4 is tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. And this page is complete. So most students are probably like, sweet, this is going quick, I don't even have to do anything, but now is your chance to do the exact same thing with copper sulfate. So, quick preview. Again, this is before, this is after, so subtract equals. Much like the other page, this answer goes on top, this answer goes on bottom, times it by 100, and you'll get a percentage. That's this page. Take this percentage to the next page. Take it to the next page. We're going to rinse and repeat exactly what we just did, but with some new numbers. So take that percentage here as grams. Find the molar mass on the periodic table. That's H plus O. Do that here. Very similar. Whatever this percentage is, you're going to take 100 minus the percentage to get grams down here. Do the conversion of the anhydrous compound. In this case, it's copper sulfate, so copper plus sulfur plus 4 oxygens. And set it up just like the other page. Do that busy work here. The answer that you get from this one, you put on top. The answer you get over here, you put on bottom. And that's the answer that you'll get to put down here. And you'll use the prefix down here. So go back to the previous lab and rinse and repeat exactly what we did there. I'll give you a little hint here. For this one, copper sulfate should be 159.62 grams. And again, water should be about 18.02 grams. So I'll give you a minute to try that busy work now. Alright, last page of busy work before you can submit to my Mac. Page 159's got 4 questions. Let's tackle the first 2. They're identical other than the answer. So percentage of water, that's piece divided by the whole. So here is your piece, this is your whole. So take 7 times H plus O divided by 7 times H plus O on the periodic table. But now add magnesium, add sulfur, and add 4 oxygens. That's not 40, that's O for oxygen. And then times that by 100. And that'll give you our percent water. The exact same thing here. You're going to find out that drywall is not very dry. And that should help you answer question 3. Why again is drywall used in houses if it's so dry? Or is it? Lastly, number 4 is a mock experiment of exactly what we just did. So here's your before. Here's your after. So take those and subtract. That'll give you grams of water. If you take grams of water and you divide it by 1.002 grams of the original, you'll get, times it by 100, you'll get percent water. Take that percent water and convert it to grams just by changing the unit from percentage to grams. You'll have grams of water. You'll set up and do 1 mole of water over grams of water. This should be our 18.02. So notice it's identical to what we just did. This will give you, because grams will cancel, this will give you moles of water. Whatever is not water is now calcium sulfate. So we have grams of calcium sulfate. Again, this would be the 100 minus the water percentage, whatever that is. These two need to add up to 100 total. Same kind of idea. 1 mole of calcium sulfate per gram of calcium sulfate on the periodic table. That would be calcium plus sulfur plus 4 O's. I'll save you some time. That's 136.14. we get moles of calcium sulfate. So identical to the cobalt chloride and copper sulfate examples already, this is calcium sulfate. So put this number on top, put this number on the bottom, round it to the nearest whole number. This one, if you do it correctly, is going to be a hydrate. So a lot like a Dodge truck is half of a real truck, this is half of a real water, and you'll see that in your answer. And that finishes this lab.